Impact of anticipated 60% reduction in drone threats across defense, agriculture, and telecommunications by mid-2025, and insights from global defense analysts on competitive developments in NATO and Eastern Europe. Introduction. In recent years, the proliferation of drone technology has transformed various sectors, including defense, agriculture, and telecommunications. As a response to the evolving drone landscape, particularly highlighted by the ongoing conflict in Ukraine, global defense analysts project a significant 60% reduction in drone threats by mid-2025. This report summarizes the insights from experts on the competitive developments within NATO and Eastern Europe, emphasizing the necessity for enhanced counter-unmanned aerial systems (C-UAS) capabilities and strategic adaptations. Context of drone utilization in Ukraine. The war in Ukraine has become a pivotal case study in the role of drones in modern warfare. Both Ukrainian and Russian forces have extensively employed drones for various purposes, including reconnaissance, surveillance, and strikes. High-end military drones, such as the Bayraktar TB2, alongside inexpensive commercial drones, have been utilized effectively by both sides. This conflict has underscored the dual nature of drones as tools for both offensive operations and critical vulnerabilities in defense strategies. The Ukrainian forces' innovative use of commercial drones for low-cost operations such as intelligence, surveillance, and reconnaissance (ISR) roles has demonstrated the effectiveness of such platforms in combat. The conflict has led to a marked increase in the adoption of drones, raising the urgency for robust C-UAS systems to counter these threats effectively. Key insights from analysts on C-UAS developments. 1. Enhanced C-UAS capabilities. The European Union's Courageous project aims to standardize testing methodologies for C-UAS systems. Through extensive research and analysis of over 800 drone incidents, the project has identified vulnerabilities in existing frameworks, emphasizing the need for robust detection and neutralization systems. 2. Interoperability and adaptation. As drone technologies evolve, NATO and individual nations must adapt quickly. Key recommendations include enhancing UAS and C-UAS capabilities with an emphasis on interoperability, human resources training, and leveraging innovative technologies. 3. Human resource development. The effective deployment of UAS and C-UAS systems hinges on human resources and training. Analysts highlight the need for a skilled workforce capable of operating and maintaining these systems in increasingly complex environments. For operational readiness, the consensus among defense analysts points to the critical importance of operational readiness. A well-trained workforce that can adapt to the evolving drone landscape is vital for maximizing the effectiveness of UAS and C-UAS capabilities. 5. Strategic integration. NATO discussions extend beyond technical aspects, emphasizing the need for a comprehensive doctrine guiding UAS operations across different domains, including air, land, and sea. Timeline of key events. Pre-2022, initial concerns over drone usage with limited C-UAS frameworks in place. February 2022, Russia's invasion of Ukraine marked a significant uptick in drone utilization in warfare. Mid-2022, both NATO and the EU recognized the necessity for enhanced UAS and C-UAS capabilities based on lessons learned from the conflict. Late 2022, early 2023, the Courageous project conducted thorough research on drone incidents, leading to the development of standardized testing scenarios for C-UAS systems. 2024, the expected completion of NATO's Alliance Ground Surveillance AGS program and the introduction of new UAS capabilities. Mid-2025, analysts predict a significant reduction in drone threats driven by improved C-UAS systems and international collaboration. Challenges and recommendations for NATO. As NATO faces the implications of drone warfare, several challenges must be addressed. 1. Limited interoperability. NATO's diverse UAS capabilities hinder operational cohesion. A concerted effort to standardize communication protocols and data formats is essential. 2. Capability gaps. NATO must assess and fill critical capability gaps concerning armed UAS and long-range ISR capabilities, particularly in light of lessons learned from the Ukraine conflict. 3. Survivability of platforms. The vulnerability of existing UAS platforms to modern air defenses necessitates investment in self-protection capabilities and exploration of new technologies. 4. Personnel training. Enhanced training programs for UAS operators and analysts are crucial to ensure effective integration and utilization of these systems. 5. The collaboration and innovation. NATO should leverage innovation efforts among member states and the private sector to enhance UAS and C-UAS capabilities. Conclusion. The anticipated 60% reduction in drone threats by mid-2025 is predicated on a multifaceted strategy involving enhanced C-UAS capabilities, operational adaptations, and a commitment to ongoing training and development. As NATO and its allies navigate the complexities of modern warfare, particularly in Eastern Europe, the insights gained from the Ukraine conflict will serve as a critical framework for future operational success and the evolution of drone technology in defense strategies. The establishment of standardized practices, robust training programs, and collaborative efforts will be essential in addressing the challenges posed by the rapid advancement of drone capabilities in the theater of military operations. The anticipated 60% reduction in drone threats by mid-2025 is based on several counterintuitive insights derived from ongoing developments in drone technology and military strategies, particularly influenced by the conflict in Ukraine. Here are the key counterintuitive elements identified in the content. 1. Drones as both tools of warfare and targets. While drones have been widely recognized for their offensive capabilities in modern warfare, particularly in the Ukraine conflict, they also expose vulnerabilities in military strategies. The rapid proliferation of inexpensive commercial drones used for ISR intelligence, surveillance, and reconnaissance roles has led to their increased use by both state and non-state actors, revealing a duality in their role as both tactical advantages and as significant threats that need countermeasures. 2. The cost-effectiveness dilemma. The report highlights that traditional high-end air defense systems are not cost-effective against low-cost drones. For instance, using $1 million missile to intercept a drone worth a few $100s is economically unsustainable. This insight suggests that future defense strategies must evolve to address the cost-to-benefit ratio in terms of drone threats, pushing for the development of more cost-effective C-UAS solutions. 3. Interoperability challenges. Despite NATO's collective approach to defense, the integration of UAS capabilities across member states presents unexpected challenges. The diversity of systems, protocols, and operational procedures complicates interoperability, which is essential for effective multi-domain operations. This situation is counterintuitive because one would expect that a unified military alliance could easily achieve operational coherence, but the reality is that national interests and varying capabilities hinder this goal. 4. The role of human resources. The necessity for skilled personnel and training in utilizing UAS effectively is often underestimated. The transition to drone warfare involves significant human capital, as the complexity of operating and integrating these systems requires extensive training and expertise. The high demand for ISR products and the need for rapid decision-making in combat scenarios further emphasize the importance of investing in human resources, contradicting the assumption that automation would reduce personnel needs. 5. Emerging technologies and counter-drone strategies. The report suggests that while technology is rapidly evolving, the integration of advanced systems like AI and directed energy weapons in combat scenarios is still in its infancy. The expectation that these technologies will seamlessly enhance capabilities may not materialize as quickly as anticipated, highlighting a gap between technological advancement and practical application in military operations. 6. Collective intelligence sharing limitations. The content also points to the limitations in intelligence sharing among NATO allies, which can be counterintuitive given the alliance's structured approach towards collective defense. The reluctance of member states to share sensitive information can hinder operational effectiveness, illustrating a paradox where collaboration is essential yet often obstructed. 7. Economic considerations in military strategy. The discussion of the financial implications of drone warfare indicates a shift in how military capabilities are evaluated. The emphasis on economic sustainability in military strategies, particularly regarding drone threats, suggests that future military engagements will increasingly consider the economic dimensions of warfare rather than purely tactical or technological factors. 8. The psychological impact of drones. The use of drones in warfare has not only tactical implications but also psychological impacts on both sides of the conflict. Drones enhance situational awareness but can also demoralize troops and civilian populations due to their omnipresence. This dual effect underscores the complex role that drones play beyond their immediate operational capabilities. 9. Regulatory and ethical considerations. The integration of drones into military operations raises regulatory and ethical questions that are often overlooked in discussions about technology in warfare. The balancing act between leveraging drone capabilities and adhering to legal and ethical standards presents a counterintuitive challenge for military strategists who must navigate the implications of these technologies on human rights and international law. 10. Future warfare complexity. The anticipated evolution of UAS capabilities towards collaborative operations and swarming tactics reflects a shift in military paradigms. The expectation that future conflicts will be characterized by highly coordinated drone activities introduces complexities that traditional military strategies may not adequately address, suggesting a need for new doctrines and operational concepts. In summary, while the anticipation of a 60% reduction in drone threats is optimistic, it is underpinned by a range of counterintuitive insights that challenge conventional military thinking. The interplay between technology, economics, human resources, and strategic adaptation will be critical in shaping the future landscape of drone warfare and countermeasures. The report outlines an anticipated 60% reduction in drone threats across defense, agriculture, and telecommunications by mid-2025, driven by advancements in counter-unmanned aerial systems (C-UAS) capabilities and lessons learned from the Ukraine conflict. While the main conclusions and projections are crucial, several important but easily overlooked aspects deserve attention due to their significant implications for future strategies and policies. 1. Impact of commercial drones in warfare. The report highlights the role of inexpensive commercial drones in the Ukraine conflict, which has often been underestimated compared to high-end military systems. This shift in warfare dynamics demonstrates that traditional military dominance is being challenged by low-cost, high-impact solutions. The ability of smaller, commercially available drones to perform reconnaissance and even strike missions effectively illustrates a democratization of military capability. This trend is significant because it implies that nations, including those with limited defense budgets, can enhance their military effectiveness without extensive investment in advanced technology. Significance. This aspect emphasizes the need for NATO and allied forces to develop C-UAS capabilities that can effectively address the threats posed by such commercial drones. It also suggests a shift in procurement strategies where emphasis might need to be placed on countering smaller, more agile threats rather than only focusing on high-end military assets. 2. Standardization initiatives through the Courageous Project. The Courageous Project's focus on standardizing C-UAS testing methodologies is a critical yet often overlooked detail. By analyzing over 800 drone incidents, the project aims to enhance understanding of C-UAS system capabilities, improve preparedness against evolving threats, and facilitate global dissemination of results. The development of standardized scenarios will allow for more accurate assessments of C-UAS technologies and their effectiveness. Significance. Standardization can lead to interoperability among member states, which is crucial for cooperative defense strategies. The establishment of common frameworks will also streamline training and operational readiness, enabling a quicker response to drone threats. 3. Operational readiness and human resource development. The report stresses the importance of human resources in training and maximizing UAS and C-UAS effectiveness. This highlights a gap in current military training models that may not adequately prepare personnel for the rapid evolution of drone technologies. The emphasis on creating a skilled workforce capable of operating complex UAS systems is a crucial factor that can determine the success of defense initiatives. Significance: investing in human capital is essential for leveraging technological advancements. As drone capabilities evolve, so must the training methodologies to ensure personnel can effectively operate and respond to emerging threats. This points to a broader need for defense forces to adapt their training approaches continually. 4. Integration of new technologies. The potential integration of artificial intelligence (AI), advanced data architecture, and autonomous systems into UAS operations is discussed. But the report also indicates challenges in this integration process. The adaptation of these technologies into existing frameworks requires significant investment and a shift in operational concepts. Significance: the incorporation of AI and autonomous systems could dramatically enhance situational awareness and operational effectiveness. However, this also raises ethical and operational questions regarding the use of autonomous weapons and decision-making processes in combat. Addressing these concerns is crucial for maintaining operational integrity and ethical standards. 5. Multi-domain operations and interoperability. The report emphasizes the importance of multi-domain operations, which involve integrating UAS capabilities across air, land, sea, and cyber domains. The challenges of achieving interoperability among various national systems and the need for joint doctrine development are crucial points that require further exploration. Significance: effective multi-domain operations are fundamental for modern military strategies. The ability to operate seamlessly across various domains will enhance NATO's collective defense capabilities. The development of joint doctrines and standardized practices is essential for ensuring that all member states can operate cohesively in joint operations. 6. Cost-effectiveness of C-UAS solutions. The report addresses the cost-to-benefit ratio for countering drone threats, particularly regarding the deployment of expensive air defense systems against low-cost drones. The need for cost-effective solutions that can efficiently neutralize various UAS threats is a recurring theme. Significance: as drone technology becomes more accessible and prevalent, defense strategies must evolve to avoid unsustainable cost burdens. This calls for innovative approaches that balance effectiveness and affordability, ensuring that military capabilities remain viable over the long term. 7. Legal and ethical considerations in C-UAS deployment. The report touches on the legal uncertainties surrounding C-UAS operations, which can hinder effective implementation. As drone technology evolves, the legal frameworks governing their use must also adapt to address new challenges. Significance: establishing clear legal guidelines for the use of C-UAS technologies is imperative to ensure compliance with international law and ethical standards. This is particularly important as the potential for autonomous systems grows, necessitating discussions about accountability and decision-making in warfare. Conclusion: the anticipated reduction in drone threats by mid-2025 is predicated on a confluence of factors including technological advancements, operational strategies, and the evolving nature of warfare. While the report provides a comprehensive overview, the nuances associated with commercial drone utilization, standardization initiatives, human resource development, integration of new technologies, multi-domain interoperability, cost-effectiveness, and legal considerations are critical components that warrant deeper analysis. Addressing these aspects will be essential for NATO and allied nations to effectively navigate the future landscape of drone warfare and enhance their collective defense strategies. 1. Impact of the Ukraine conflict on drone usage and countermeasures. The ongoing conflict in Ukraine has significantly influenced the understanding and application of drone technology in modern warfare. Both Ukraine and Russia have extensively utilized drones for reconnaissance, tactical support, and direct strikes, highlighting their strategic importance in contemporary combat scenarios. This situation has catalyzed the development of Counter-Unmanned Aerial Systems (C-UAS) capabilities as both NATO and individual nations recognize the need to protect against the diverse threats posed by drones. The lessons learned from the conflict underline the necessity for robust C-UAS frameworks, which are essential for ensuring operational readiness and safeguarding critical infrastructures. 2. Technological advancements in C-UAS systems. The anticipated 60% reduction in drone threats by mid-2025 is largely attributed to advancements in C-UAS technologies. Projects like the European Union's Courageous initiative are paving the way for standardized methodologies aimed at enhancing the effectiveness of C-UAS systems. This includes developing robust detection, tracking, and identification technologies to counter the evolving drone threats. By analyzing over 800 incidents, the Courageous project is establishing comprehensive testing scenarios that will improve preparedness and response capabilities against hostile drone activities. The focus on interoperability and the integration of new technologies such as AI and multispectral sensors will be crucial for future operational success. 3. Strategic recommendations for NATO and allied forces. The need for NATO and its allies to adapt rapidly to the evolving drone landscape is paramount. Key recommendations include enhancing UAS and C-UAS capabilities, fostering interoperability among different systems, and leveraging technological innovations to counter drone threats effectively. A comprehensive doctrine that encompasses UAS and C-UAS operations across all domains, air, land, and sea, is essential for cohesive and effective military strategies. Moreover, investment in human resources training and operational readiness is critical for maximizing the effectiveness of UAS and C-UAS systems in future conflicts. 4. The role of AI and emerging technologies. The integration of artificial intelligence, AI, and other emerging technologies into drone capabilities represents a transformative shift in military operations. AI can enhance the operational efficiency of UAS by improving data analysis, threat detection, and autonomous decision-making processes. The development of autonomous systems will enable more complex and coordinated missions such as swarming tactics and collaborative operations with crewed aircraft. NATO's focus on harnessing AI and other disruptive technologies will be vital for maintaining a technological edge and addressing the multifaceted challenges posed by advanced drone warfare in future combat scenarios. Here are 3 famous historical cases that reflect the themes of drone technology and its implications for military and civilian operations. Similar to the anticipated reduction in drone threats. 1. The use of drones in the War on Terror 2001-present. The War on Terror has seen the extensive deployment of unmanned aerial vehicles (UAVs), particularly in regions like Afghanistan, Iraq, and Yemen. The U.S. military has used drones for targeted strikes against terrorist leaders and organizations, fundamentally changing the nature of warfare. This case highlights the dual-use nature of drones, where they serve both military objectives and raise ethical concerns regarding civilian casualties and sovereignty violations. The reliance on drones has sparked debates over their effectiveness and the need for robust counter-drone systems to protect against potential retaliatory strikes from adversaries utilizing similar technology. 2. The 2016 Nagorno-Karabakh conflict. The 2020 Nagorno-Karabakh conflict showcased the transformative role of drones in modern warfare. Azerbaijan utilized a combination of armed drones, including Turkish Bayraktar TB2S, to conduct precision strikes against Armenian forces. The conflict revealed how drones could effectively disrupt traditional military strategies and highlighted the necessity for counter-drone measures. The Armenian military faced significant challenges in defending against these UAVs, demonstrating the need for advanced detection and neutralization systems to mitigate drone threats on the battlefield. 3. The 2022 Russian invasion of Ukraine. The ongoing conflict in Ukraine has further underscored the significance of drones in contemporary warfare, with both Ukrainian and Russian forces employing a mix of military and commercial UAVs for reconnaissance, artillery targeting, and strikes. Ukraine's use of inexpensive commercial drones for tactical ISR intelligence surveillance and reconnaissance and strikes against high-value targets has become a focal point of its resistance against Russian aggression. This situation has prompted discussions about the need for effective counter-UAS capabilities to protect critical infrastructures and assess the evolving landscape of aerial warfare, suggesting that a significant reduction in drone threats may hinge upon the implementation of robust C-UAS systems and international cooperation. The future outlook for drone threats and countermeasures in defense, agriculture, and telecommunications is poised for significant transformation, with predictions suggesting a 60% reduction in drone-related threats by mid-2025. This optimistic forecast is rooted in advancements in counter-unmanned aerial systems (C-UAS) technology and strategic adaptations informed by recent conflicts, particularly the ongoing war in Ukraine. 1. Technological advancements in C-UAS. The primary driver behind the anticipated reduction in drone threats is the rapid evolution of C-UAS technologies. Projects like the European Union's Courageous initiative are pivotal in standardizing C-UAS testing methodologies, addressing vulnerabilities in existing frameworks and facilitating international collaboration. By analyzing over 800 drone incidents, these projects have highlighted the need for more effective detection and neutralization systems. 2. Global security context and NATO developments. The geopolitical landscape, particularly in NATO and Eastern Europe, is crucial to understanding future drone dynamics. The war in Ukraine has demonstrated both the offensive capabilities of drones and the necessity for effective countermeasures. NATO is responding by enhancing interoperability among member states and integrating advanced technologies such as artificial intelligence (AI) and machine learning into drone operations. The establishment of joint doctrines and operational concepts will further streamline C-UAS capabilities across the alliance. 3. Shifts in operational tactics. As drone warfare becomes increasingly sophisticated, military forces are adapting their tactics. The use of drones for reconnaissance, strike missions, and even psychological operations has expanded. C-UAS strategies will focus on not only neutralizing threats but also countering drone swarms and autonomous systems. Training personnel to effectively manage these technologies will be essential, as will the integration of C-UAS into broader military frameworks. 4. Future of drones in agriculture and telecommunications. In agriculture, drones will continue to revolutionize precision farming, enabling farmers to monitor crops, manage resources, and improve yields. The anticipated decrease in malicious drone activity will likely create a safer environment for agricultural UAV operations, allowing for more widespread adoption. In telecommunications, drones will play a crucial role in enhancing connectivity, particularly in remote areas. Their ability to deliver internet access and facilitate communication during emergencies will become increasingly valuable, provided that C-UAS measures effectively mitigate any associated risks. 5. Conclusion. The future of drone threats and countermeasures is characterized by rapid technological innovation, strategic military adaptations, and expanded applications across various sectors. With the expected 60% reduction in drone threats by mid-2025 driven by advancements in C-UAS technologies and international collaboration, the landscape will shift toward a more secure and integrated approach to drone utilization in defense, agriculture, and telecommunications.